Systems of equations are points of intersection. So anytime that you're asked to solve a system of equations, we want to look for points of intersection. There are going to be times where there are more than one intersection point, and there's going to be times where there's no intersection point, which means your system has no solution. So for this quadratic and this line, it has one intersection point here, and we would list that as the order pair 2, 3. So we're just saying that that x and that y value make both of those equations true. And again, if they don't touch anywhere, then there is no solution to the system of equations. In Math 1, you also had a scenario where you could have infinite solutions, which is where they were both graphing the same line. So all the points were the same. In Math 1, when you solve systems of linear equations, you had one solution. So what changes in other function families and types of equations and rules and things like that is that we have more than one intersection point. So we're going to graph this line. We need to get it into y equals mx plus b form first in order to graph. So we're going to move the x to the other side. So I'm going to start at -2 because that's the y-intercept. The slope is 1, which means I'm just going to go up 1 over 1 to keep finding points on that line, and then we can see where the line is going to intersect the circle, which happens at 2 places. So we have 2 points of intersection, and we would just list the order pairs 1, -1, and 4, 2. Same thing for number 4. I need to move that 2x to the other side to get it into the y equals mx plus b. -7 is going to be down here off of the graph. The slope is a -2, so I'm going to work backwards to find other points. So I'm going to go up 2, so that would be at -5, which would be here, and then to the left 1. So up 2 to the left 1. And you always just want to make sure when you're plotting that you're thinking about, if it's a negative slope, it should be looking like it's going downhill when I read the graph left to right. So again, we have 2 points of intersection with a circle and a line. So this would be at -4, 1, and -2, -3. If you're just given the system to graph, then we're going to use Desmos to do that. So we would just go in to Desmos and plot the system. So this is a quadratic function and a line, which means we could have no intersection point, we could have one intersection point, we could have 2. So you may have to kind of drag and move around. And then, of course, the nice thing about Desmos is we just click and find the answer. So we have 2 intersections for that system of equations, one at -1, 4, and one at 6, 1. So if we're given a word problem, so the price of one model of a vintage record player in a 4-week period was given by P of x is equal to x squared minus 3x plus 3. So we're going to go over to Desmos. We're going to plot and graph that line. The price of the second model is given by the linear function, the opposite of x plus 6. So again, we would graph that on the same coordinate plane. Did these models ever have the same price in those 4 weeks? So for this problem, we have to think realistic domain. If it's time and money, I'm only interested in the first quadrant. So the solution over here we're going to ignore. We want the one to the right. So at 3, 3, they would have the same price. And our answer is in hundreds of dollars. So that Y value means $300. Number 10, one bicycle's distance traveled along a track is given by d of t is equal to 1/2 t squared plus 2. The other one's at 4t minus 4. Were the bikers ever side by side? So again, to be side by side, they have to be at the same distance. So I'm looking for the intersection. So I have to use x. Desmos is not going to recognize any variable other than y and x. If you put another variable in, it's going to ask you to use sliders and set up restrictions. So just change those to x's instead of t. And then we can see on that graph that they had 2 points in time. So at about 1.1 second, and then at about 6.8 seconds, they were at the same distance, so they would have been side by side.